These travelers are trying to locate a remote village in the interiors of Rajasthan.
Take on the right.
But for this map, they would have wandered around endlessly. In a giant leap, Ravi has found his place in the sun. He has identified his house and tagged it with his name. Down the years, anyone accessing this map on the internet will know that a man named Ravi Mehta once lived here. For Shruti, it is an easy task to locate the Scandinavian countries on the globe for completing her geography home assignment. All this has been made possible by the advent of a detailed map, the result of an intensive collaborative effort, mapping. Down the ages, humankind has demonstrated an innate desire to explore the unknown. This has been partly fueled by the need to look for a suitable place to settle. A land surface that has good vegetation and which has an abundant supply of water. In fact, history provides ample evidence of civilizations that have flourished near water sources. In their quest for a better lifestyle, human beings started migrating, leading to the development of entire civilizations all over the globe. The discovery of natural resources fired the imagination of the more adventurous, resulting in a new migratory movement. It was at this juncture that the concept of a map took shape. Necessity is the mother of invention, a worn-out cliché, but true nevertheless. The explorers required to know their exact location, the distance to the nearest source of livelihood, the location of the migratory site with reference to the original starting point, and so on. This triggered the development of a hard drawing, which would serve as a guide and give them the desired information. Primitive maps were made on the skins of animals. With the passage of time, maps became more refined and precise. They now showed various topographical details like hills, open land, lakes and marshes, alternative paths to a location, the distances involved, and the available surrounding resources. All these constituted the two-dimensional forms of the mapping element. However, in addition to these, there were three-dimensional elements as well, like mountain tops, forest cover on hilly surfaces, varying terrain heights, visibility in inundating terrain, etc. These three-dimensional elements could change their arrangements during various seasons. For example, forests could shrink and water sources could diminish. These changes, known as the time dimension of a map, also needed to be depicted in order to make the map truly effective. The data required for map making was obtained by ground surveys, which constituted a critical element of the exercise. The reference coordinate system for ground surveys was established using astronomical observations by measuring the azimuth and elevation of fixed stars with respect to a given point. After establishing a few points, this way, the positions of other points were derived by processes known as triangulation and traversing. In triangulation, the basic principles of spherical trigonometry are used to get the position of unknown points through measurements of angles and distances. The great trigonometrical survey is one of the finest examples of long-distance traverses carried out by British and Indian surveyors. Through these traverses, the Great Arc from Mount St. Thomas in erstwhile Madras and Bannog Point near Mussoorie was established. The distance between these points is of the order of 2,400 kilometers, and the arc passes through geographically difficult to traverse areas. The entire length of the arc was actually traversed on foot, carrying very heavy equipment like the Great Theodolite, calibrated chains, etc. All observations were reduced to the positions of the intermediate points using hand calculations and recorded in tables by hand. Mr. Lambton, a British officer, was one of those who lost their lives while carrying out this survey of the Great Trigonometrical Arc. A significant contributor to this exercise was Sir George Everest, in whose honor the highest peak in the world has been named. A large number of Indian surveyors contributed to the survey as human computers. Native Indians transported survey equipment and people during the journey. This gigantic task took more than 50 years to complete, and the lives lost in the process were more than the number of lives lost in contemporary wars in the same region. Once the position of a set of points called geodetic reference points was known, the whole region was mapped at an appropriate scale by locally measuring the relative distances from these points. It would be interesting at this point to know that the 0 milestone of the country is located at Nagpur. This is supposed to be the dead center of the country. The 0 mile pillar is used for distance measurement in all 4 directions of the country. The Survey of India, which is the premier mapping agency of the nation, is located in the beautiful city of Dehradun. It dates back to the days of Lord Clive, when Major James Rennell was made the first Surveyor General of Bengal in 1767. The Survey of India provides a comprehensive range of services to meet the geospatial information needs of the country, such as disaster preparedness, natural resource management, and vital infrastructure development. Mapping consists of the following basic elements. 1. Generation of reference points as a geodetic control. 2. Triangulation to obtain individual map control. 3. Ground survey to obtain a classified set of features and their positions on the map. 4. Map generalization, a process of data smoothing appropriate to the scale of the map. 5. Map symbolization as per a defined standard. 6. Indexing for map sheet nomenclature as per a defined standard. 7. Map compilation. And 8. Map publishing. Traditionally, maps have been prepared on large-sized sheets. The compilation of several categories of information was done on mylar sheets. The process of preparation was extremely tedious and time-consuming. However, with technological advancement and the emergence of the Geographical Information System (GIS), we have been able to overcome these problems. GIS allows storage, of geospatial information in digital form as several layers with associated attribute tables containing detailed information about each map object. This helps in answering complex queries related to mapping. For example, it makes it easier to locate industrial sites, or for that matter, any other large man-made structures such as dams or, say, lakes. The GIS has a massive database which can help the planner negotiate related queries better and in turn arrive at superior options. In times of disaster, the availability of multi-layered GIS information is vital in planning and carrying out rescue operations, saving human life and property.
2, 1, 0.
Space technology too plays a vital role in mapping. It offers solutions to the mapping problem in three ways. Firstly, through space-borne remote sensing image acquisition. Secondly, through a constellation of orbiting satellites for navigational support. And thirdly, through communication satellites enabling instant voice and data transmission among field parties and map-serving laboratories. Once acquired from the satellites, space-borne remote sensing images need little refinement or correction to help arrive at the ortho-rectified image mosaics. Terrain undulations are modeled using stereo imagery acquired from space in the form of a digital elevation model using a few precisely located ground control points. Field visits are essential in order to acquire missing ground information such as names, features, and other attributes in the space images. The field data collection is aided by handheld computer devices storing corrected satellite data from the laboratory. Each device is fitted with a navigational satellite data receiver called GPS to give its approximate location in the field. This information is then carried to the laboratory to derive the vector map information. The efforts which have been put in by a variety of experts and field people now need to be consolidated to convert the satellite images from a raw form to a readily usable, up-to-date map for the end user. This calls for an internet-enabled web portal which acts as a platform for communicating with each of these experts and service providers for this task. The portal will also serve the resulting maps to the end users, who could query the map contents, interact, and possibly even update the temporal variations. Let's look at some striking examples of collaborative mapping. Space-based information dissemination to the fishermen for optimal fish catch. Navigation and control of a fleet of vehicles like ambulances, police vehicles, taxis, fire service vehicles, etc. A silent yet vital component of this massive collaborative effort is the contribution of hundreds of school children and postmen who gather vital field information. Scientists contribute in converting uncorrected satellite images to ortho-rectified image mosaics using ground control points and digital elevation model, interpret and delineate features, all of which render map making possible. To quote the Honorable Union Minister of Science and Technology and Earth Sciences, Mr. Kapil Sibal, the Indian geospatial industry will be bigger than the IT and telecom industry. In the near future, collaborative mapping has a prominent role to play to be an instrument to the development of society at large.